In this example, we will learn about three angle types: degrees, radians, and revolutions. In Part A, we'll define each term. One degree is defined as 1/360th of a full rotation. The diagram shows a terminal arm rotated 1 degree. One radian is the angle formed when the terminal arm swipes out an arc that has the same length as the terminal arm. The animation shows a terminal arm rotating 1 radian. The length of the arc is r, which is the same length as the terminal arm. One radian is approximately 57.3 degrees. Radians are expressed as unitless quantities. If you see an angle written as 3 without the degree symbol, it means 3 radians. Another way to visualize 1 radian is to do the following. Build an equilateral triangle with 2 pieces of wood and a flexible piece of metal. Now bend the triangle so the metal side pops out into an arc that corresponds to a circle with a radius of r. The angle between the pieces of wood is now 1 radian, or 57.3 degrees. One revolution is defined as 360 degrees, or 2 pi. It is 1 complete rotation around a circle. Note that radian angles are often expressed as multiples of pi. This is done because an angle like 2 pi is an exact value, but its decimal equivalent 6.28 is just a rounded approximation. In Part B, use conversion multipliers to answer the questions and fill in the reference chart. A conversion multiplier is simply a fraction that is equivalent to 1. The numerator has units that we are trying to obtain, and the denominator has units that we are trying to eliminate. You've probably been using conversion multipliers for a while already. For example, to convert 3 kilometers to meters, we perform the calculation shown. The fraction 1,000 meters over 1 kilometer is the conversion multiplier. The unwanted units, kilometers, cancel out, leaving the desired units, meters. Now we'll use conversion multipliers to convert one type of angle to a different type of angle. We can convert degrees to radians with a conversion multiplier pi over 180 degrees. Note that pi can be thought of as having units of radians, but this is usually left unwritten. Multiply 23 degrees by the conversion multiplier. Use your calculator to get the numerical value 0.40. Degrees cancel, leaving units of radians. Use estimation to see if this answer makes sense. 23 degrees is about 40% of 1 radian, which is 57.3 degrees. 0.40 radians is also 40% of 1 radian. Therefore, 23 degrees and 0.40 radians are approximately the same angle. Now we'll move on to the next conversion. We can convert degrees to revolutions with a conversion multiplier 1 revolution over 360 degrees. Multiply 23 degrees by the conversion multiplier. Use your calculator to get the numerical value 0.06. Degrees cancel, leaving units of revolutions. We can use estimation to see if this answer makes sense. 23 degrees is about 1/16 of a circle. 0.06 revolutions is about 1/16 of one revolution. Therefore, 23 degrees and 0.06 revolutions are approximately the same angle. Now we'll move on to the next conversion. We can convert radians to degrees with the conversion multiplier 180 degrees over pi. Multiply 2.6 radians by the conversion multiplier. While radians are normally expressed without units, it's acceptable to use rad, short for radians, as a unit. This is especially helpful when using conversion multipliers. In this conversion, the radians cancel, leaving units of degrees. .6 radians is approximately 148.97 degrees. We can use estimation to see if this answer makes sense. If 1 radian is 57.3 degrees, then 2.6 radians is approximately 149 degrees. We get this with the calculation 2.6 times 57.3 degrees is approximately 149 degrees. Therefore, 2.6 radians and 149 degrees are approximately the same angle. Now we'll move on to the next conversion. We can convert radians to revolutions with the conversion multiplier 1 revolution over 2 pi. Multiply 2.6 radians by the conversion multiplier. Use your calculator to get the numerical value 0.41. Radians cancel, leaving units of revolutions. We can use estimation to see if this answer makes sense. 2.6 radians, or 149 degrees, is about 40% of a circle. 0.41 revolutions is about 40% of a circle as well. Therefore, 2.6 radians and 0.41 revolutions are approximately the same angle. Now we'll move on to the next conversion. We can convert revolutions to degrees with the conversion multiplier 360 degrees over 1 revolution. Multiply 0.75 revolutions by the conversion multiplier. The units of revolutions cancel out, leaving 270 degrees. Use estimation to see if this answer makes sense. 0.75 revolutions is 3/4 around a circle. 270 degrees is also 3/4 around a circle. Therefore, 0.75 revolutions and 270 degrees are approximately the same angle. Now we'll move on to the next conversion. We can convert revolutions to radians with the conversion multiplier 2 pi over 1 revolution. Multiply 0.75 revolutions by the conversion multiplier. The units of revolutions cancel out, leaving 4.71 radians. Use estimation to see if this answer makes sense. 0.75 revolutions is 3/4 around a circle. If 1 radian is 57.3 degrees, then 4.71 radians is approximately 270 degrees. We get this with the calculation 4.71 times 57.3 degrees is approximately 270 degrees. Therefore, 0.75 revolutions and 4.71 radians are approximately the same angle. In part C, contrast the decimal approximation of a radian with the exact value of a radian. When radians like 2.6, 4, or negative 0.712 are the result of a calculation, we call these values decimal approximations of a radian. They are not exact values since information is lost when rounding occurs. Radians like 3 pi, 5 pi over 4, and negative 3 pi over 2 are called exact value radians. In mathematics, exact values are considered more valuable than decimal approximations. Completing the intermediate steps of a multi-step problem using decimal approximations compounds information loss and yields unpredictable answers. Using exact values avoids this problem since no rounding needs to occur and the final answer will always be the same. Convert 45 degrees to a radian. In this conversion, the answer should be expressed as an approximate decimal. Multiply 45 degrees by the conversion multiplier pi over 180 degrees. Degrees cancel out, leaving 0.79 radians. Now we'll convert 45 degrees to radians a second time. In this conversion, the answer should be expressed as an exact value radian. Start the conversion the same way as before, using the conversion multiplier pi over 180 degrees. Multiply to combine the values into one fraction. Note that degrees cancel. Reduce the fraction 45 over 180 to 1 over 4. The exact value radian is pi over 4. You can use your calculator to help reduce fractions. Type in 45 over 180 without the pi to get 0.25. Press Math, select Fraction, option 1, and press Enter twice. The calculator will return the reduced fraction, 1 over 4.